without if I have a shape? How do I find missing sides? I just want to clarify one more time. We have learned several things already, so as we go through the rest of this chapter, you're going to use these things. So first of all, if I have a right triangle, one thing I can use if I know two sides and I want to find the missing side is what? Pythagorean theorem. So we can use a squared plus b squared equals c squared. That's always an option if it's a right triangle. However, a couple of students throughout all 6 classes, I had a couple who were all of a sudden on this last test using Pythagorean theorem. Pythagorean theorem only works if it is a right triangle. You can't just throw it out on any triangle. So be careful. You only use that if it's a right triangle and if you know two sides. Then we've talked about special right triangles. We had some special right triangles that were 30, 60, 90, and 45, 45, 90. Did we review this last class period? Okay, I would write this down if you've forgotten because this is going to be coming back up today. So 30, 60, 90 we learned way back last semester, and I can promise you it's going to be in this chapter, it's going to be in chapter 11, and it's going to be in chapter 12. You're going to have to remember these. So if you didn't do well last semester with this, now's the time to master it, okay? So remind me, what was across from the 30? Not 2L. It's the smallest angle, it's the smallest side. L. What was across from the 60? Not 2L. Nope. L square roots of not 2, 3. And then what was across from the 90? Now you say 2L. Okay? So it goes from smallest to largest. 1L, this is about 1.7L, and this is 2L. So smallest to largest. What was across from the 45? Not 2L. L. And across from the other 45? L, because remember if it's a 45, 45, 90, it's isosceles, which means these are the same. What was across from the 90-degree angle on the hypotenuse? Nope. L square roots of 2. Okay, so you are going to have to remember that. Write it down, memorize it. You're going to use that, but you can only use that if it's a special right triangle. So if it does not tell you it's a 30, 60, 90 or a 45, 45, 90, you can't just make up numbers in those angles and say, oh, it's 30 and 60. It could be anything. So you cannot do that unless it's special. So we have one option that works when you know two sides. We have another option that works if it's a special right triangle. Last class period, we learned another option, but it had to be a right triangle with an altitude drawn from the right angle. If it was this special case, then we had two shortcuts called geometric mean shortcuts that we learned. One of them was the altitude squared equals what? Nope, you were right the first time. Part of the hypotenuse times the other part of the hypotenuse. And then the second shortcut we learned was leg squared equals what? Whole hypotenuse. Very good. Times the part of the hypotenuse adjacent to the leg. So Landon, this is the part that you missed when you weren't here on that lesson, so highly encourage you to watch the video over that to try to make it make more sense. But we basically learned two more shortcuts if it was this special kind of triangle, but only if it's this special kind of triangle. And so what we're going to learn today is, well, what do we do when it's not, we can't use Pythagorean theorem because we don't know two sides, or it's not a special right triangle, and it doesn't have an altitude drawn in it. But it's still a right triangle, and we still want to know what are the missing sides or the missing angles. And so what that leads us to is some trig ratios. And first of all, I want you to understand why these ratios work. So I just want you to look up here with me for 1 minute. I'm going to show you something on the board. We talked the other day about if you have two right triangles and they have the same angle, like maybe 32 degrees and 32 degrees. What do we now know about these two triangles if these two angles are congruent to these two angles? What's the two triangles are going to be similar, and that makes the side lengths proportional. So in other words, if I were to put, let's say, 3, 4, 5, which is a very common Pythagorean triple, and this, actually, I'm going to make this one the bigger one since it looks bigger. So let's say this is 3, 4, and 5, and this is now proportional, so it's growing by the same rate, 6, 8, 10. They talked in the video about the OPP, the HYP, and the ADJ, right? Did you guys catch that in the video? What that's referring to is if you have a triangle and you're looking at one of the two acute angles. So in the video, they used Greek letters. They used the theta symbol. I don't know if you caught that, but he mentioned that in the video. So you can call this anything you want. Theta, alpha, beta, any Greek letter is often used in trig. You don't have to use a Greek letter. You can use the actual vertex letter. Maybe this is A, B, C, and you just want to call it angle A and angle B. But oftentimes in math textbooks, they're going to use Greek letters for those angles. So just be aware of that. If you see that, don't let that freak you out. So let's say that I'm looking at just this angle B or theta. You're going to need to first be able to label the sides of your triangle. The first side should be really easy to label, and that's the one that's across from the 90-degree angle. What do we always call this side? Hypotenuse. So in the video, that's why it was the HYP. Then you're going to label the other two sides depending on which angle you're looking at. If you're looking at angle B, it's going to be one thing. If you're looking at angle A, it's going to be a different thing. So if I'm looking at angle B, what would I call this side? Would I call it the OPP or the ADJ? OPP. What does OPP stand for? Opposite. What does ADJ stand for? Adjacent. So if I'm looking at this angle, across from it is the opposite side, and touching the angle would be the adjacent side. So in the video, it talks about you got to be able to recognize, first of all, which sides are you even looking at, right? If I switch angles, make sure you see this. If I switch angles, two of the sides change, one of them does not. If I'm looking at this angle A, which two sides are going to switch? The opposite and the adjacent. The hypotenuse can't change because it's always across from the right angle. But now if I'm looking at angle A, do you see that this side becomes the opposite side? And this side is now the adjacent side? So those two are relative to the angle. Which angle are you looking at? That determines what you label them. Okay? So what I want to show you is if you have right triangles, and they have two angles that are congruent, it does not matter how big they get or how small they get. Their sides are always going to be proportional. And so what happens is that there's some relationships that are the same when we compare their sides. So for example, let's say I'm looking at this 32-degree angle. What would I call these sides? Opposite, adjacent, or hypotenuse? Opposite. What would I call the sides with the 10 and the 5? The hypotenuse. And then that leaves the 3 and the 6 to be the adjacents. Okay? So notice what happens when I look at some ratios here. For example, let's say I take the opposite side and divide it by the hypotenuse. What's the opposite side? 8. What's the hypotenuse? 10. What does that reduce to? 4/5. Go to this triangle. What's the opposite side? 4. What's the hypotenuse? 5. Do you see that the opposite over the hypotenuse will be the same number no matter how small it is or how big it is? If we're looking at a specific angle measure, across from the 32-degree angles, it will not matter how big it gets or how small it gets. When you write the opposite over the hypotenuse, it will always reduce to the same value. Okay, the same thing's going to happen for two other special ratios. So this time, let's look at the adjacent and the hypotenuse. Okay, what's adjacent to this 32 degrees? 6. What's the hypotenuse? 10. So adjacent over hypotenuse would be 6 over 10. What does that reduce to? 3 over 5. Now go to this triangle, 32 degree angle. What's the adjacent? 3. What's the hypotenuse? 5. Do you see that it reduces to the same ratio? Okay, last one that I want to look at is, which again, these were in the video. If you caught them, it was really fast and quick. The last one was the opposite over the adjacent. So let's go back to this triangle again, 32 degrees. What's the opposite side? 8. And what's the adjacent side? 6. So 8 over 6, what does that reduce to? 4 over 3. Now go to this triangle. What is adjacent, or excuse me, opposite? 4. What's adjacent? 3. Do you see that it reduces to the same ratio? So what they discovered when they realized with right triangles, if you're looking at a specific angle in that right triangle, no matter how big the triangle gets or how small the triangle gets, if it has the same angle measure, the ratio of two sides will always be the same value. Opposite to hypotenuse will always be the same value for every right triangle that has a 32 degree angle, or a 50 degree angle, or a 70 degree angle. The ratio will always be the same number. And so those ratios are our trig ratios. They're called the sine, the cosine, and the tangent. And SOHCAHTOA is going to be your friend. It's going to help you remember which ones go with which, and I'll explain that in a minute. So when you look at this picture here on your notes, if you'll look at this first part, are they stapled back? Okay, no, they're good. So it's going through basically what I just talked about over here on the board, a little less detailed. By angle similarity, you've got right triangles that are similar. Therefore, the sides end up being proportional and reducing to the same ratio. A trig ratio, by definition, is just simply a ratio of two sides of a right triangle. So this is a trig ratio, this is a trig ratio, and this is a trig ratio. They each have a special name that's associated with them. And these are the three trig ratios that I just wrote on the board. So the first one is called the sine. The sine compares two specific sides. It compares the opposite side to the hypotenuse. So you're going to have to memorize the sine of an angle is equal to the opposite over the hypotenuse. Notice it's spelled S-I-N-E. On all of these, they're going to truncate the word down to 3 letters. So instead of calling it S-I-N-E, they're just going to put S-I-N. It does not make it a sin. Okay, it is still sine. Cosine gets chunked down to just C-O-S, but it's still read cosine. And tangent gets shrunk down to tan, but still we say tangent. Okay? So first one is called the sine, and all it is it compares the opposite side to the hypotenuse. The second trig ratio is the cosine, and it compares the adjacent side to the hypotenuse. And the third trig function is the tangent, and it compares the opposite side to the adjacent side. The order matters. You can't flip that over. It is opposite over adjacent. Adjacent over hypotenuse. Opposite over hypotenuse. Okay, so that is where this little acronym comes into play. Back in my day, many, many years ago, my teacher taught this to me. And to help me remember how to spell it, because if you can't spell SOHCAHTOA, it doesn't help you, my teacher taught me this little phrase. Some old horse caught another horse taking oats away. And this many years later, I still remember SOHCAHTOA. Some old horse caught another horse taking oats away. That way I could remember how to spell it. Is it an O or is it an A? Is it an O or is it an H? How do I know how to spell it? So some old horse caught another horse taking oats away. The reason to memorize that is so that you can remember your three trig ratios. Sine is equal to, what's the O stand for? Opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. And then tangent is equal to opposite over adjacent. Okay, was this the class that got to have Mrs. King as their guest teacher? All right, so Mrs. King introduced me to a little PG version versus my nice G version. Back in my day, it was some old horse caught another horse taking oats away. But when I met Mrs. King, who's full of spirit and fun, laughter, she taught me a different way to remember it. And you can use this if it helps you. But again, it's a little bit more PG-13 versus G, okay? So Lashley would say, some old horse caught another horse taking oats away. But here's another fun way to remember it. Please use whatever works for you. Make up your own and share it with us as long as it is appropriate, okay? So SOH, CAH, TOA, got to know how to spell it. So here's what she had heard. Some old hippie, is that how you spell hippie? Caught another hippie tripping on acid. Okay, so please understand Lashley is not endorsing any kind of drug use whatsoever. Totally not okay. But just a fun way to try to remember. You've got to come up with something in school that helps you remember things. And so little acronyms oftentimes will be the best way to do that. The whole goal is that you're going to remember these three trig ratios. You have to have them memorized. And to have them memorized, SOHCAHTOA is a great way to remember it. SOHCAHTOA, SOHCAHTOA. We'll watch the video again. It'll help us remember it. But if you can't spell SOHCAHTOA, doesn't help you at all. So you need to know, how can I remember how to spell it? And so if you can think of a little phrase like, some old hippie caught another hippie tripping on acid, or some old horse caught another horse taking oats away, or whatever you prefer, you need to memorize the trig ratios, okay? This is important here, so look at this little slide. In trig, the letter of the vertex of the angle is often used to represent the measure of that angle. I've been very picky that you write things like this, measure of the angle equals. But when you write it in trig, you're going to write sine, and then you just put the letter. So instead of putting sine angle A or sine of the measure of angle A, you just put sine A, where A represents the angle measure. Or it may be that they use Greek letters and it's sine theta equals, okay? So it just depends on what the problem looks like. But angle A, angle B, or theta, or alpha, or beta, whatever letter, this is talking about the angle measure. Trigonometry is more of the study of triangles, more specific than geometry, which is the study of all shapes. And then it leads into the pre-calculus part of it, where the great thing, did Ms. Dennett come talk to your class about? Yeah. So then you can find out more, like I'm teaching you rigid shapes that oftentimes in real life aren't the case. I mean, right triangles happen a lot in construction when you're building because you have a lot of right angles in construction. But in real life, a lot of times if you're trying to calculate the area of a surface, it's not often a nice rigid shape. It's curved, it's circular, it's wavy, and that's where calculus comes into play. You can calculate the volume or the area of objects using calculus. So it's kind of just that stepping stone to get to. The bad thing about mathematics is at the lower level, it's hard to see a connection. It's not until you get into that higher math that it's really real life useful. And so until you get up there, it's kind of sometimes you just have to accept that you have to learn it. And then depending on what you do with your life, you may get to that high level of math where you actually use it in real life, or you may not. So, but there's some things in geometry like calculating the area of your room to know how much carpet you need, which could be for anybody. If you're going to put new carpet in your house or paint a wall or put cement and you need to know how much do I need to buy, then that's real life for anybody. Okay? But that's what trig is, kind of the study of triangles. All right, so first kind of question that we're going to have to use our trig for is just simply understanding these ratios. So this is not solving for anything yet. It's just, do you really understand what sine, cosine, and tangent is? So first example in your notes, all it says is write the trig ratio as a fraction, number 1, and as a decimal, number 2, rounded to the nearest hundredth. So all they want you to do is use these trig ratios to find out what is the sine of j. Okay, so we're going to go first of all to angle j. The very first thing you need to do is figure out which side's the opposite, which side's the hypotenuse, and which side's the adjacent, or you can't work the problem correctly. I usually start with my hypotenuse because it can't change. What's the hypotenuse in this picture? 61. So label this HYP. What is the opposite side? 60. We're looking at angle J. If you change the angle, that changes which one's the opposite. So this is the opposite side. What's the adjacent? 11. Okay, so first question just simply says, what is the sine of J? And your answer is just going to be a fraction. You're just going to write down what is the opposite over the hypotenuse. So sine of J would equal what over what? And again, I'm going to write down opposite over hypotenuse to try to help me start to remember. SOHCAHTOA, sine opposite hypotenuse. So it's going to be 60 over what? 61. Stop. That's the first thing it asked for. What is the trig ratio as a fraction? 60 over 61. I do want to warn you, if it can be simplified, you need to simplify it. So if it was 6 over 8, I would expect you to reduce that. Okay? The second thing it asks you to do is give that answer as a decimal rounded to the nearest hundredth. It's just asking for this fraction rounded to the nearest hundredth. So take your calculator, type in 60 over 61. What is it? 0.98. Everybody agree? So that's approximately 0.98. That's the second part of the question. It did not ask you for angle J. It did not say find the measure of a side or the measure of an angle. That's where we're headed, but that's not what this question asks. Every year I have students who miss this simple problem because they go too far, because we're getting ready to learn how to go farther. This just says, write the trig ratio as a fraction. What's the sine of J? 60 over 61. Are you with me? Okay, let's try the next one. Oops. What does this one want? Cosine of J. Same picture, right? So we already had it labeled. 61 was the hypotenuse. Still looking at angle J. So 60 is still the opposite, and 11 is still the adjacent. But what is the cosine of J? What's my two sides I'm going to compare? Adjacent over hypotenuse. That's the C part, C-A-H. So what's the adjacent side? 11. What's the hypotenuse? So circle it. The first part said write it as a fraction. We can't reduce 11 over 61, right? And remember, if you don't know, take your calculator, type it in, 11 divided by 61, and then what do you do to change it back to a fraction? Math, enter, and it will give you the lowest possible reduced fraction. Okay, so if you're unsure, type it in, math, enter. All right, then it says round to the nearest hundredth. So now type it in, round it to the nearest hundredth. What is it? Sorry, 0. What? 18. Circle it. Two answers here. Is this making sense? Okay. One more. Be super careful on this next one. What does it ask you for? Tangent of K. So what did we just switch? We switched the angle. We're not looking at J anymore. Now we're looking at K. So that changes the way we label our triangle. One side never changes, though. What side never changes? Hypotenuse. but the opposite and the adjacent depend on what angle you're looking at. So now what's the opposite of K? 11. And the adjacent is now 60. And again, the reason I label my hypotenuse first is because the hypotenuse is adjacent to 60 or to K as well. But it's not called the adjacent because it's called the hypotenuse, okay? All right, so tangent, what is tangent equal to? What over what? Opposite over adjacent. So what's the opposite side? 11, and the adjacent? 60. Circle it. And then round it to the nearest hundredth. What do we get? 0.18. Okay, so first kind of problems they're going to ask you to do are just simply write down what is the sine of an angle, what is the cosine of an angle, what is the tangent of an angle. Any questions on that first kind of problem? Okay, the next thing that they're going to ask you to do, I'm going to skip this, we're going to come back to it. That's probably the hardest part. The next thing they're going to ask you to do is be able to calculate what is the sine of a specific angle measure. So we're going to use our calculator to plug in the sine button, the cosine button, and the tangent button. Now I want to make sure I'm clear here. The reason why we don't just teach you this all along and teach you all of these options, Pythagorean theorem, special right triangles, geometric mean shortcuts, is because this is going to give you rounded answers every time. This gives you exact answers in simplest radical form. This gives you a rounded number. So we use this as our last resort. If we can't do either of these options, now we can use trig. Okay? All right, so we're going to use our calculator to figure out what's the sine of 52 or the cosine of 52 or the tangent of 52. But here is what is huge. To measure an angle, there's two ways you can measure an angle. You can measure an angle in degrees, and you can measure an angle in radians. Two different angle measures. Different ways to do it. Just like taking a ruler and measuring in inches or centimeters. That's two different answers, right? So you have to make sure your calculator is in degree mode. If it's not in degree mode, every single problem you do will be wrong. When you go to take the ACT, nobody's going to tell you to make sure your calculator's in degree mode. If you drop it and the batteries pop out, if I change the batteries, if you reset the memory, it puts it back into radian mode. That's the default mode. Because when you take trig or pre-cal, oftentimes you need to measure it in radians instead of degrees. And so the calculator is automatically defaulted to radians. But for geometry, for our purposes, this little symbol means what? Degrees. So when you see that little symbol, you've got to think, I got to make sure my calculator's in degree mode. So here's how you do that. I'm going to show my calculator in a minute. But again, I'm going to warn you. You go to take the ACT Aspire test coming up. I can't tell you to put your calculator in degree mode. And the state law requires me to reset the memory on every calculator before you test. You have to remember, I walk in, I pick my calculator up, I immediately change my calculator to degree mode. Okay? You go take the ACT test, you're going to have to remember to put your calculator in degree mode. If you don't remember, every problem you do will be wrong. And if it's multiple choice, do you think they're probably going to have one of the answers being in the wrong mode? So be careful, okay? All right, so here's my calculator. I want to make sure it's in degree mode. I go to mode. Where's the mode button? Right by the second button. Do you guys see where it says mode? We're going to type that button, and then we've got these options. We don't want ours in radian. We want it in degrees. So we're going to arrow down to the third row. We're going to arrow to the right, but notice it's just flashing. Radian is still highlighted. You have to hit enter so that it highlights it. Okay, so mode, arrow down, arrow over to the right, hit enter so that it now highlights degree. And then you're good to go. You can just hit second mode and that quits out of that screen. Second mode. And now it's in degree mode. Okay, what does this question want you to type in? Sine 52. So now find your sine, cosine, tangent buttons. Do you see those on your calculator? They're right here. Sine, cosine, tangent. Be careful. There's also these little blue ones up above. Do you guys see the sine to the -1, cosine to the -1, tangent to the -1? We're going to talk about those next class period, not today. But to get to those, you would have to hit the second button. Okay, so when we get ready to find those, that's what we'll do. But right now we don't want those. We just want regular trig functions, sine, cosine, tangent. So you're going to type in sine 52, enter. Oops, not what I did. Sine 52, enter. And what's the sine of 52? 0.7. What did it ask us to round to? Nearest hundredth. So this would be tenths, hundredths. The 8 tells me to round this to a 9. So this is 0.79. Any questions on using your calculator to just plug it in, type it in, evaluate? Okay, so you'll have some questions like that on the homework, where it's just grab your calculator, type it in. Now, if you do not have a graphing calculator, that's okay. You don't need one. You just need a scientific calculator. A lot of iPhones or telephones or computer screens, you can Google and look up apps that are free, but a lot of them, if you just pull the regular calculator, looks like this. If you turn it, looks like this, right? And it has your sine, cosine, tangent buttons on it. So if I wanted to type in the sine of 52, the only thing you have to do different on these is you have to type in the angle first. So a lot of scientific calculators require you to type in the 52 first and then hit sine. Okay? So it's okay if you don't have a graphing calculator. I think every one of you probably have at some tool, whether it is one at home, a phone, a computer. Your Chromebook should be able to give you a scientific calculator, or at least you can look up a scientific calculator for free online. You do have to change the mode if it's not in degree mode already. So on your calculator, like on your phone, I don't know, can you see this very well? Let me put it under the doc cam. And you're welcome to get out your phone right now if you want to play with it on your phone for a second, if that's what you're going to use. But if you look right here, do you see this little button on mine that says RAD, rad? That means radian. So if this says radian, that means I'm in degree mode. If I want it in radian mode, oh, obviously I can't touch that. Holy moly. If I want it in degree mode or radian mode, then I'm going to hit that button so that it says radian up here. So this is in radian mode because it says radian up here. If I want it back in degree mode, I'm going to go back and hit this button. It doesn't say degree mode, but it says I can change it to radian mode. So I know I'm in degree mode. Does that make sense? Okay. All right. So feel free, and if you don't have access to anything, you get home tonight and you're like, I can't find any way to get a scientific calculator, come by tomorrow and see me, and I have some small scientific calculators I could check out to you to use. But you don't need a graphing calculator. Your phone will work just fine if you have one of those, or you should be able to access one online through your Chromebook. Your Chromebook may even have a calculator on it. I'm not real familiar with the Chromebook, though. So, any questions about how to use yours? Okay, so that's the first thing. We're trying to get to our ultimate goal, which is to be able to solve for missing sides or angles. So we now know how to set up a trig ratio. We now know how to type it into our calculator. I'm going to skip this for now, just for time purposes. And now we're going to get to the real reason we're learning this. Here is a right triangle. I need to find the length listed. What length have they asked me to find? BC. When I look at this picture, I'm looking for BC. I'm going to put an X here. First thing I notice is it's a right triangle, but I only know how many sides? 1. Can I use Pythagorean theorem if I only know one side? No. Second thing I notice is this angle is 15 degrees. Can I solve this with special right triangles? No. Third thing I notice is I have a right angle, but I do not have an altitude drawn from the right angle. So I can't use what I just learned last class period. So I'm stuck until the wonderful world of trig. And now I can use trig. Here's what you want to do every time, though. When you get to a problem like this, first decide which angle are you going to use. You are never allowed to use the right angle. It doesn't work. You have to use the acute angles. When we're talking about SOHCAHTOA, we're talking about the acute angles in the picture, not the right angle. Make sure I've got that clear. You're never writing down sine of 90, cosine of 90, tangent of 90 to solve this problem. Pick an angle. You could use either one because you should be able to find angle A. How do we find angle A? Okay, subtract 15 from 90 or add these two and subtract them from 180. But my advice is don't do that unless you have to, because what if you subtract wrong? Now you've got the wrong angle, you're going to get everything else wrong. So I would use what they've already given you, the 15 degrees. Now you're going to label the side that you know and the side that you're looking for. Only label those two sides because that's going to tell you which trig function to use. Okay? So label the side you know. What would we call this side in the picture? Opposite. And then label the side you're looking for. Adjacent. Even though we have this hypotenuse blank, they didn't ask me to find it, so leave it blank. That's going to tell you which two sides you're going to use as your ratio. Which trig function uses opposite and adjacent? Tangent. Opposite and adjacent is the tangent. So once you figure out what side do I know, what side do I want to know, that'll tell you which trig ratio to use. So you'll start with tangent. You'll write tangent of, you have to have an angle. You cannot find the tangent of nothing. There has to be an angle there. So we're finding the tangent of what angle? 15 degrees. So you're putting tangent of 15 equals. So it's sine of an angle equals opposite over hypotenuse. Cosine of an angle equals adjacent over hypotenuse. There has to be an angle like we were talking about our 32 here. Okay, so tangent of an angle equals opposite over adjacent. So that means we're going to have tangent of 15 equals what? 10.2 over x. Now at this point, there's two ways you can work this problem. I'm going to show you probably the way that most teachers would tell me not to show it to you. But the reason I'm going to do it is because this is what you are comfortable, you've been doing over and over again all last chapter. I'm going to have you write this as a proportion, cross, multiply, and solve, because we've been doing that and we're good at it right now. So if first of all, I need you to understand what tangent 15 means. Take your calculator and type in tangent 15. What do you get? Okay, you get a number, right? The tangent of an angle is just a number. Just a number. This all stays together. You can't separate it. Tangent is nothing by itself. It has to have an angle associated with it. This is all one number and it's just a number. How do I make a number a fraction? How do you make 5 a fraction? Put it over 1. So if I have tangent 15, I can make it a fraction by just putting it over 1. Now I have a proportion, and I can cross multiply and solve. The video is going to show you a trick. You can use the trick once you're good at it, but until then, I'm going to write them as proportions and cross multiply. Okay? So we can do it like this, cross multiply. When I do that, I get x times tangent of 15. Again, that's all one number, all goes together, equals what? 10.2 times 1, which is just 10.2. Now what do we do? Remember, tangent of 15 is just a number. And a number times x, if we want to get x by itself, what do? Divide. So we're just going to divide, keep it all together, by the tangent of 15. It's just a number. It just looks different than what you're used to seeing it. You with me, Caleb? Okay. So these cancel, and we're left with x equals. And now it says round your answer to the nearest hundredth. So you're going to take your calculator and you're going to type in 10.2 divided by tangent 15. So again, 10.2, oops. I went too fast. Come on. 10.2 divided by the tangent of 15. Okay? And we round it to the nearest hundredth, so what's our answer? 38.07. And that's our answer for the length of BC. Remember that you write it equals BC without a line segment above it. No line segments. Questions? Okay? If I want to use my phone, because I don't have a graphing calculator or a scientific calculator, just real quick to make sure you understand how to type that in. So now I'm looking at my phone. I'm still going to do 10.2 divided by, but now I have to type in the angle first. So it's going to be 15, then tangent, and then I have to hit equals. Are you with me? Questions? Okay, good. So Samsung's better because it lets you type it in just like you would on the calculator. Okay? All right. So if you have a question, I can help you individually with that. So all I did different, Ruben, was on this one, I typed it in starting with our 10.2 divided by, which is exactly what we did on the calculator. But on the iPhone, you have to type in the angle before the trig function. So I want to do divided by tangent 15. Instead, I'm going to have to do divided by 15 tangent. And then you have to hit enter, because you already typed in 10.2 divided by 15 tangent. That's what 15 tangent is. Now you hit, oops, I don't know what I typed in. 10.2 divided by 15 tangent, and then hit equals. I did away. Oh, thank you. Is that making sense? Okay. And again, if you have trouble, that's something I can help you with over the phone or before it's due, whatever. Okay. Let's try another one. So look at your notes. This is just, again, my picky rules, but also most mathematicians are going to tell you, do not ever round until the final step of your answer, ever. So if it's not your final answer, you keep carrying in all the value on your calculator. Use the values you have, and then at the very end, round. Don't round all along the way. So if you get to multiple steps on the problem, wait until the very end to finally round your answer. Okay, so this one says find the length. What are we finding? QR. So on your paper, X. Which angle are we going to use? 63 degrees. Label your picture with your side you know and the side you want to know. What side do we know? RP, and that is what in my picture? Which one of these options? Careful. It's across from the right angle, so it is the hypotenuse. Remember, your hypotenuse can't switch. It's always across from the right angle. Okay, so what does that make X, the side I'm looking for? Careful. Opposite. Adjacent means it's got to touch the 63-degree angle, but X is across from it, so it's the opposite. All right, which trig function uses opposite and hypotenuse? Sine. SOHCAHTOA. So we're going to do sine of what angle? 63 degrees equals good. Opposite over hypotenuse, so it is X over 12.9. What do we do next? Okay, put it over 1 and cross multiply. We want to make these both fractions so that we have a proportion. And then cross multiply. When we cross multiply this time, notice when the X is in the top, it changes it a little bit. What is X times 1? X. And then we have 12.9 times the sine of 63. Be very, very careful. This is not 63 times 12.9. This is 12.9 times sine of 63. This is one number altogether. It doesn't get separated. Do not multiply 12.9 times 63 and then take the sine. You'll get the wrong answer. 12.9 times sine 63. Type it in on your calculator, round it to the nearest hundredth, tell me what you get. Say it again, Gavin. Somebody agree? Not what you got? Try it again. 11 point what? 49? Okay, it's 493, so the 3 tells me to round the 9 by leaving it alone, so it is 11.49. Okay, if it's 11.493, to round to the nearest hundredth, you look at the one after the hundredth. If it's less than 5, you leave it alone. If it's greater than 5, you round it up. So it would be 11.49. Gavin, did you figure out what you did wrong? Okay, be real careful. Is this making sense, guys? So pick the angle you're going to use, label the side you know, label the side you want to know, pick which trig function you can use then, and then set up your problem as a proportion, cross multiply, and solve. And it is a way to find missing sides in right triangles when you can't use one of our other methods. Okay? All right. Let's see what we have left in the notes. Do we have a word problem next? No, this one. You guys try this one on your own and then we'll check it. Well, you don't have, is it? Okay, but you don't need the hypotenuse. You're not looking for the hypotenuse? And, oh no, that is what you're looking for. Okay, so again, I would only label the side I'm looking for and the side they give me, because that's going to tell me which trig function to use. I don't know this side, and I don't know this side, so those are not the two sides I should be labeling. You want to label the one you know and the one you're looking for. Okay, let's check it. So first of all, which angle are you using? 39. Okay, again, you can't label everything. If you label all the sides, you're not going to know which trig function to use. Label the one you know. Which side do we know? Okay, but it's the side that has the number 20 on it, right? So is that adjacent, opposite, or the hypotenuse? It's the adjacent side. So label it, and then label the side that you're trying to find, because you can only have one variable. So if you labeled the two sides you don't know, you're not going to be able to solve the problem. What is FD? Hypotenuse. You have to label only two sides to know which trig function to use. So now, which trig function uses adjacent and hypotenuse? Cosine. Adjacent and hypotenuse. SOHCAHTOA. So we're going to do cosine of what angle? 39 equals adjacent, which is 20, over the hypotenuse, which is x. So be really careful. Once you do that, again, put it over 1, cross multiply. This time we end up with x times the cosine of 39 equals 20. Stop me right now if you're not understanding, because the rest of the entire chapter is about this. Okay, from here, what will I need to do to solve for x? Divide by the cosine of 39. Remember, that's just a number. It's all together, it's just a number. Beside? Because it is adjacent over the hypotenuse. So when I look at angle 39, the adjacent side is 20, and the hypotenuse is FD, which is what we're looking for, so I called it x. So adjacent is 20, hypotenuse is x, adjacent over hypotenuse. Does that really make sense? Okay. Divide by the cosine of 39, type it in on your calculator, rounded to the nearest hundredth. What do we get? 25.74, and I forgot probably on all of these, so I want to make sure these should have units. What is my triangle side lengths measured in here? Meters. Go back and let's see, did I forget that on the other ones? Did they have units? Okay, let's go back and fix it. On this one, it should have been 11.49 centimeters. On the one before that, it should have been, oops. Thank you. I didn't write it down though. It was x equals what? Okay, and that was feet. So watch your units around your triangle. Whatever the sides are measured in, that's what your answer should be measured in. Any questions before we look at the last thing today? Okay, we have one. I'm not going to do the word problem. If you have a word problem, just read it, set your picture up. It's the same kind of thing. But let's go back to the part that we skipped. There were some examples we skipped. And it should be, oops. Right here, right? Okay, on this part of your notes, put no calculator. On your test, you will get 0 credit if you use your calculator. And I will know that you used your calculator because your calculator cannot give you answers in simplest radical form. So if you use your calculator, you're going to have decimals. This says use special right triangles to write cosine of 30 as a fraction. The ones I'm going to give you on the test are probably going to end up with radicals, and therefore it'll be very obvious if you use your calculator. So it'll say no calculator on the test. Don't use your calculator. So use special right triangles to find the cosine of 30. So write this down with me. We're going to draw a right triangle. In our right triangle, what kind of angle are we going to have? 30-degree angle, which means our other angle has to be what angle? 60. So what we're going to do for these problems is we're going to find the cosine of 30 without our calculator. We're going to find the exact value. Calculators only give us a rounded answer. So we're going to find the exact value of the cosine of 30, and we're going to do that by using our formula. So we just reviewed it on the board this morning. What is across from the 30? L. What's across from the 60? L square roots of 3. What's across from the 90? 2L. And you're going to, again, have to memorize it or you won't be able to work these problems. So you should be writing this down to have this example. Okay, so we want to find the cosine of 30. So now once I label my formula, I'm just using the formula. I don't have any numbers, just the formula. I'm looking at the 30-degree angle. Cosine is which two sides? Adjacent and hypotenuse. So the cosine of 30 should equal the adjacent over the hypotenuse. Okay, so we're going to look at the 30-degree angle and we're going to identify what's the adjacent side and what's the hypotenuse. Which side is adjacent? L square roots of 3. Which side's the hypotenuse? 2L. If you're having trouble, find your hypotenuse first and then ask yourself, which one touches the 30, which one's across from the 30, and that'll help you with your adjacent. So now, in my problem, I'm going to say the cosine of 30 should equal the adjacent. What's the adjacent side? L square roots of 3 over, what's the hypotenuse? 2L. Okay, what can I do with those L's in the top and the bottom? Cancel them out. You will not be left with an L in your problem, ever. If you are doing this correctly, the L's will always cancel. I don't know what happened there. Come on. My little signs went away. Sorry. Okay, the L's cancel. So what are we left with? Square root of 3 over 2. That is your answer. You can check it on your calculator. Type in the cosine of 30 right now. What do you get? Okay, now type in the square root of 3 divided by 2. Make sure you stop the square root before you divide by 2. Square root of 3 divided by 2. What do you get? 0.86, same thing, right? So you can check, did you do it correctly? But your answer can't be 0.86. Okay, really quickly, let me remind you, go to the next one real fast. Can't get it to work. What's the next one say to find? Tangent of 45 degrees. Okay, tangent of 45. So if I do the tangent of 45, I'm using this right triangle, 45, 45, 90. Tangent of 45, or when I use my special right triangle, remember this is L, L, and L square roots of 2. Tangent is which sides? Opposite and adjacent. So pick a 45-degree angle. It will not matter which one. Pick one. Okay? What's the opposite side? L. What's the adjacent side? The other L. So if I do tangent of 45 and it's opposite over adjacent, what am I going to get? L over L. What is L divided by L? 1. If you check it on your calculator, type in tangent of 45, what do you get? 1. Okay, the only thing I want to warn you about, and then we're done, is what if you end up with something like this? Are you allowed to leave your answer as 1 over the square root of 2? No. What did we learn to do if we have a square root in the bottom? Multiply by the square root of 2 over the square root of 2. So what does this become? One times square root of 2 is just square root of 2. What's the square root of 2 times the square root of 2? Square root of 4, which is 2. Okay, do not leave a square root in the bottom. Okay, homework is due when? Tuesday. Don't wait till Monday night. You will be frustrated because you'll struggle. Do it tonight. That's it. And then call or text me if you need help. Come to Encore tomorrow. Work on it during Encore. That way you don't have to even take it home and work on it. Due Tuesday, because we do not have school on Monday.